Hello there, this is Ms. Nakayama, and today's lesson is 9.2, the hyperbola, not to be confused with hyperbole that you study in an English class. This is the hyperbola. And in today's lesson video, we're going to cover locating the hyperbola's vertices and foci. We're going to write equations of hyperbolas in standard form, and we're going to graph hyperbolas that are centered at the origin and not centered at the origin. Now, before I go on, I want to refresh your memory. We talked about in the last video, 9.1, ellipses, that the definition was that an ellipse was the set of all points in a plane such that the sum of the distances from two fixed points was a constant. Well, in a hyperbola, we have the set of all points in a plane such that not the sum, but the difference. So from two fixed points is a constant. So PB minus PA, as you can see up here, is always 2, no matter where I am. So this curve, and actually it's both of these curves, okay, from these two fixed points. When I subtract any point on this curve and I subtract the distances, I'm always going to get 2. Okay, so really why I wanted to show you the two, one was so that you understood the difference. Ellipse means we're adding the distances. Hyperbola means we're subtracting the distances. And as I mentioned to you in ellipse, the focus, these two fixed points, which we called foci, are always inside the curve. So this is the curve of my hyperbola, and those are the foci. So to continue, all right, those curves are called the branches. All right, and the branches, as we said, when the branches cross the axis, the line through the foci that intersects the hyperbola at 2 points is called the vertices. So where the branches, this right here, these are your branches, where they cross that axis, those are your vertices. We have some other ones up here that we're going to talk about later. The line segment that joins those vertices is called the transverse axis. And if you can kind of remember, we've got vertices or vertex in the word transverse. So that's called your transverse axis. Next, we have the midpoint, of course, of the transverse axis is the center of the hyperbola. And as I mentioned to you before, those points, those fixed points are called the foci. Each one is a focus, and they're always inside the curve. Okay? And we'll talk more about what the other axis is called, not called a minor. In the ellipse, we had the major and the minor axis. In the hyperbola, it's called a transverse axis and a conjugate axis. And you'll see more of that as we go on. Okay? So if you remember those definitions, it's easy to remember the standard form of the equation. And we're centered at the origin right now. But the main difference between this and what we did with the ellipse is the hyperbola is always a minus because it's the difference of the distances. Okay, so what you want to remember about that is that A is always under the positive term, and I just shorten that by saying A is greater than 0. Well, A is always greater than 0 because, I mean, it's A plus or minus 0, but it's a short way to tell you or to remind yourself that A is under the positive term. This term is positive, this term is negative because there's a minus sign in front of it. Okay, and if X is the positive term, then the hyperbola is going to intersect the horizontal axis, the x-axis if it's centered at the origin. If Y is positive, then it's going to intersect the y-axis, or your transverse axis will be vertical. And the other thing to remember is that key equation between A, B, and C. Okay, and just like we had an ellipse, A is the distance from the center to a vertex. C is the center to a focus. And B will be this distance down here that we'll talk about when we do some graphing. What is the relationship between A, B, and C? C squared equals A squared plus B squared. So I don't know if y'all figured it out now, but when my equation, my standard equation is x squared minus y squared, then my equation down here is a squared plus b squared. Back with the ellipse, I had x squared plus y squared, and this was a squared minus b squared. So it's a way to help you remember what those equations are going to be. If you write them down every time you do your homework problems, you won't have any trouble remembering. All right, so let's talk about finding the vertices and foci from a hyperbola's equation. So first and foremost, when I'm given an equation, I'm going to find the center. And the center in this case is 0, 0. So I'm going to come down here. And just like we did in the ellipse, y'all, x squared. Under the x is 25, but I take the square root of that. So I go 5 in both directions. That is my positive term. So that means that these are my vertices. Okay? And if you want to, but we don't have to graph, so I'm not going to go any further than that right now. Okay? They asked us to find the vertices. So the vertices are going to be plus or minus 5, 0. Now they ask us to find the foci. And to find the foci, I need that other equation that's going to have a different sign. It spells cab when you square it all, but it's going to be plus. So I'm going to have c squared equals a squared plus b squared. Okay, and y'all, so if this says minus, to find this down here, I'm going to add the numbers. Back in the ellipse, this said plus, I subtracted the numbers. So I'm going to add the numbers, and 25 plus 16 is 41. The square root of 41 is approximately 6.4. And if you want to graph that, then you'll find out that the foci are there. And if you were to, I'm going to do it like this, but if I were to graph it, it would look something like this, which really bad graph, but you get the idea that the focus would be inside the curve. So to give the coordinates of the foci, I'm moving left and right, so it's going to be plus or minus the square root of 41, comma 0. And that's all we got. Okay, let's look at a different orientation. Okay, find the vertices and locate the foci for the hyperbola with the given information. So again, my center is at the origin. So I'm going to go, but notice the 25 is under y squared. So this time when I graph it, I'm graphing my 25 up and down. So that's going to be, well, that's not what I wanted. That's going to be a vertex, and that's going to be a vertex. So my vertices in this case are 0 plus or minus 5, because this is my positive term. And to find the foci, I'm still using c squared equals a squared plus b squared. I'm going to add those numbers underneath, and this time c squared equals 41, which is the same number. C equals plus or minus the square root of 41, which we said was 6.5 something. So there are your foci, again, inside the curve, because this time my hyperbola would do something like this if you were to graph it. So my vertices would be, my foci, 0 plus or minus the square root of 41. And that's it. So again, I'm not remembering any formula. I'm remembering what they are and where they are, and I'm using a picture. Okay? Now, let's go the other way. This is example 3, finding the vertices and foci from a hyperbola's equation. So I think you know, if I'm given this information, I got foci at 0, -5, and 0, 5, vertices at 0, -3, and 0, 3. So yes, I'm going to draw a picture. Okay, so I plotted those points, and I have that my foci are 5 and -5, so that's a focus, and that's a focus. And my vertices, -3 and +3. That means halfway between is my center. And as I've said before, and because I know that the vertices and the foci are on this vertical axis, I have an idea that my hyperbola is going to do something like this. Well, whatever. Y'all know what I mean, what I'm trying to do. Okay. That means that y squared is going to be my positive term, so I'm going to write it first. So y squared over something minus x squared. Well, how far did I go to the vertex? Because underneath the y is how far I went to the vertex. That is my a. So that means that a is equal to 3, and underneath my y squared, I'm going to write 3 squared, which is 9. And then I know that the distance from the center to the focus is c. So c is 5, and using my general equation, c squared equals a squared plus b squared, c squared is 25, a squared is 9 plus b squared, so that leaves b squared to be 16. So I'm just going to put 16 and be done. That's it. All we had to do. Okay, so we haven't talked about it yet in graphing these, but now we need to talk about this hyperbola, which mine are really poorly drawn. They actually have something called asymptotes centered at the origin. And remember, the branches always approach these, and an asymptote is a line that a curve approaches but never touches. Okay, so our asymptotes in this equation, all right, in both of these, there's a positive one. Okay, these are our positive ones, and these are our negative ones. Okay, meaning these have a positive slope and those have a negative slope. Now, I spent a lot of frustrating years in high school trying to remember whether it was B over A or A over B. But if you remember that the slope, this is the slope of an asymptote, is always rise over run, you can remember by looking at a picture. Rise is B, run is A. Okay? Over here, my rise is A and my run is B. Or if you look at the equation, underneath my y, it's the slope is y over x, change in y over change in x. So this one is b over a, and this one is a over b. That will help you. I think it helps you remember. Okay, if you want to pause and write these down, the steps to graphing, but I'm going to go ahead and do it, and you can see it. So, graph and locate the foci for x squared over 36 minus y squared over 9 equals 1. What are the equations of the asymptotes? So first and foremost, my center. My center is at 0, 0. So I'm going to go plot 0, 0. And just like I've done before, underneath my x squared is 36. And the square root of 36 is 6. So I'm going to go right 1, 2, 3, 4, 5, 6. And I'm going to go left 1, 2, 3, 4, 5, 6. So those are my vertices. That's a vertex and that's a vertex. Remember, this is my positive term. Okay, so when I go up and down, okay, from my center, I'm going to go up and down the square root of 9, which is 3. I choose to put an x. 1, 2, 3, 1, 2, 3. Okay, and I put the X to remind myself that that's not where I graph it. That's not where my branches are going to cross. But I use it to be able to draw it. So we draw this little box. I don't know if y'all did this last year, but using the sides of these things that we just drew, these points, then I draw a rectangle. And then I draw diagonals through, I didn't mean to do that one, through the center of the box. Really crooked, but you got the idea. So you go, I'm trying to draw it, boom, and boom. Nope, he's supposed to go like this. So that's a rough estimate of where they are, and so that means when I draw my hyperbola, from my vertex, from each vertex, I start with that point, and then I approach the asymptotes. And that's how you draw it. But it does contain the vertex. So you do want to make sure you go, that was really bad. Let's try this. Okay. And so that's what my hyperbola looks like. What are the equations of the asymptotes? Okay, well, it goes through the origin, so it's just going to be y equals plus or minus something x. Well, you can look at your picture. What did I go up? 1, 2, 3, and I went over 6. Well, up 3 and over 6 is going to be 1/2. Okay? And boom. Up here, this was 3. The square root of that is 3. The square root of that is 6. I put y over x. 3 over 6 is 1/2. So whether you choose to get it from your graph or get it from an equation, either one works, but it's a great way to check yourself. All right. Just like we did with hyperbolas, we are going to move these off of the origin. And so my center will be HK, and you just have to keep remembering that H is always with X and K is always with Y. And if you draw it the way we just did from the origin, you won't have any trouble figuring out any of the other equations. So there's your vertical. That one was horizontal. So look at this guy. This is our last example. And of course, we've got to do the completing the square because you got to know how to do that. So graph 4x squared minus 24x minus 9y squared minus 90y minus 153 equals 0. So we're setting this up. They've already kind of grouped my x's and my y's. That made it nice. I have to move the 153 to the other side. So my setup looks like this. I'm going to start off with factoring the 4 out of the x's. So I have 4 out of 4x squared is going to give me x squared. 24 divided by 4 is negative 6x. And then I'm going to do plus a blank on both sides of the equation. And then I've got 9y squared divided by 9 is just y squared. 90 divided by 9. Okay, y'all, so you're probably going to want to say it's negative 10, but it's actually positive 10. Now, why is it positive 10? Because I took out a negative 9. So it's negative 90 divided by negative 9. Very common mistake right there. So if you miss it, that's the first place you ought to look. Okay, then I'm going to say plus a blank on both sides of my equation. And remember, because these parentheses have a number in front on the outside, I'm going to put that number out front on the outside of my parentheses as well. And notice that I put the negative 9 because this is a negative 9 out front. All right, so to complete that square, I take half of 6, which is 3, and square it. Half of what? And on the other side, 3 squared is 9. Then I take half of 10, which is 5, and square it. And 5 squared is 25. So when I bring that together, remember I've talked to you about if you write it like this, makes your factoring easier. First term gives me x. Middle term gives me a minus sign. Last term gives me the 3. And then I have minus 9. First term gives me y. Middle term gives me plus. And the last term gives me 5. And when I combine 153 plus 4 times 9 plus negative 9 times 25, I get negative 36. And y'all, this is a great checking point. If these two numbers don't multiply nicely here, you've probably done something wrong most of the time. So you've probably forgotten this negative sign right here, or you didn't add it correctly to both sides. You didn't put it over here on this side. So that's just something to look for. As always, we have to make it equal to 1. So I'm going to divide everything by negative 36. Now, when I do that, notice that this term is going to be positive and this one is going to be negative. You don't have to switch the order, but I prefer to. So I did. And I have y plus 5 quantity squared over 4, because 9 over 36 becomes 1 over 4, plus x minus 3 quantity squared over 9, minus x minus 3 quantity squared over 9 equals 1. And so that is my my hyperbola. Let's go graph it. My center is at, now y'all, this is again, got to be careful. X is always with H and Y is always with K. So it's not negative 5, 3. It's going to be 3, negative 5. So I can go plot that. Come back here. 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. That's my center right there. Okay. And I have to graph it. So in the y direction, I'm going up and down the square root of 4, which is 2. Up and down 2. And in the x direction, I'm going 3, but it's that negative, so I'm putting the x. I'm just using it to be able to draw my box. And then I'm going to draw the diagonals through the box. And I'm going to go to my vertices, which are the ones that I had the point, and go towards my asymptotes. I'm not crossing your asymptotes. Easier to do with pencil and paper. Okay, we also have to give the equations of the asymptotes. So before we just had y equals plus or minus something x. Well, y'all, same concept. Just take the top here. We're putting it in point slope form. So just remove the exponent, and that's going to give me y plus 5 equals plus or minus something times x minus 3. What is the something? What is the slope? Okay, last time I went to the graph. If you want to go to the graph, find the center. I went up 2 and over 3. Y, the square root of under y is 2. The square root under the x is 3. Y over x, still 2 over 3. So those are my asymptotes. And that is all you have to hyperbolas. No word problems for you. If you really want some, let me know. I'll be happy to give you some. But thank you so much for watching, and y'all have a great day.